In this example, I need to rationalize the denominator of these three expressions here. Well, what does it mean to rationalize the denominator? What this means is that in our answer in the denominator, we do not want any irrational numbers such as square roots, cube roots, etc. that won't simplify. So looking at our first example, which is 2 divided by the square root of 3, I have an irrational number in my denominator. Now, does the square root of 3 simplify? No, this is in simplest form. And if you ever have a square root that's in simplest form in the denominator, the easiest way to rationalize the denominator is you multiply the numerator and the denominator by this square root. So I'm just going to multiply by the square root of 3 divided by the square root of 3. And why are we allowed to do this? Notice the square root of 3 divided by the square root of 3 is just 1. So I'm not changing the value of the expression I started with, I'm just changing its format. So this gives me 2 times the square root of 3 in the numerator, divided by, now in the denominator of this first one, I'm going to do it the long way to explain what's going on. Since I have a square root times a square root, I can use the product property of radicals that says that equals the square root of the product of the two radicands. So it's going to be the square root of 3 times 3 is 9. Now the numerator does not simplify. I have 2 times the square root of 3 divided by, in the denominator, what's the square root of 9? That's 3. Now can I reduce this 3 with this 3? No, one is under a radical, one is not. So that is the answer for part A. And notice I started out with the square root of 3 in the denominator, an irrational number. Now all I have are rational numbers in my denominator. In part B, I have the negative square root of the fraction 5/6. So the first thing I'm going to have to do is use the quotient property of radicals. So I'm going to have the negative, and then I'm going to break up my square root of a fraction into the square root of the numerator divided by the square root of the denominator. So I'm going to have the negative square root of 5 divided by the square root of 6. Now, can I simplify the square root of 6? Remember, 6 is just 2 times 3, neither of which are perfect squares, so I cannot simplify that. So I'm going to use the same process as I used in part A. I'm going to multiply numerator and denominator by the radical in the denominator. So I'm multiplying numerator and denominator by the square root of 6. Remember, this is just 1. And now I'm going to get the negative, the square root of 5 times the square root of 6. They're both square roots. I can multiply the 5 and the 6. I get the square root of 30 divided by, in the denominator, I'm not going to write all the steps out this time. The square root of 6 times the square root of 6 is the square root of 36, which is just 6. And lastly, can I simplify this answer? I cannot reduce the 6 with the 30, as 30 is under a radical, 6 is not. And can I simplify the square root of 30? Are there any factors of 30 that are perfect squares? No. So my answer is the negative square root of 30 divided by 6. Notice I do not have any square roots left in my denominator. And in the last example, we have 21 divided by the square root of 18. Now, I could follow this procedure immediately and multiply numerator and denominator by the square root of 18. But if I did that, I'd have a lot of simplification to do at the end. The best thing to do is to simplify the square root of 18 before I rationalize the denominator. 18 is 9 times 2, and remember 9 is a perfect square. So I'm going to get 21 divided by the square root of 9 times 2, which is 21 divided by, using the product property of radicals, in the denominator I have the square root of 9 times the square root of 2. So I'm going to get 21 divided by the square root of 9 is 3 times the square root of 2 that doesn't simplify. Now, can I reduce this 3 with this 21? Yes, neither of them are under radicals. 3 goes into 3 once, 3 goes into 21 7 times. So I'm going to get 7 divided by 1 times the square root of 2 is just the square root of 2. Now my square root in the denominator is totally simplified. I can rationalize the denominator by multiplying numerator and denominator by the square root of 2. So I get 7 times the square root of 2 divided by the square root of 2 times the square root of 2 is the square root of 4, which is 2. So that is the answer for part C, 7 times the square root of 2 divided by 2. Remember, I cannot reduce this 2 with this 2, as one of them is under a radical, one of them is not. So again, I've rationalized the denominator, and you can see there are no square roots left in my denominator.